Hi viewers at home, this is Ellis Chem. As I promised in my last video, I want to explain how to interpret orbital electron configuration. Orbital electron configuration. Firstly, what are orbitals? Orbitals can be defined as regions where there is probability of finding electrons. That is what we call orbitals. So when you have orbital electron configuration, what are the things you can decode from the electron configuration written in terms of SPDF notation? 1. The numeral written before the orbital represents the energy level or principal quantum number. For example, sodium 1s2, 2s2, 2p6, 3s1. All these numeral 1, 2, and 3, they represent the main energy level or what we call principal quantum number. Number 2, this same numeral is called coefficient. We call it coefficient. This 1, 2, 2, and 3, they are regarded as coefficients. 3, the highest coefficient represents the period an element belongs to in the periodic table. For example now, we are using the same example here. Na, which is sodium, is 11. We have 1s2, 2s2, 2p6, 3s1. If you look at this electron configuration, the highest coefficient here is 3. So therefore, this implies that sodium belongs to period 3 in the periodic table. Point number 4 that you can deduce from the orbital electron configuration is this. The numeral written as a superscript on the orbital is called index number. the numeral written as a superscript on the orbital is called index number. For example, we are still using the same sodium, which is 11, 1s2, 2s2, 2p6, 3s1. So what I'm saying is this circled number 2, 6, 1 are referred to as index number. Point number 5. The sum of all the index number in the electron configuration denotes the atomic number of that element. For instance, let's say we don't know the atomic number of sodium, and we are given sodium is 1s2, 2s2, 2p6, 3x1, and they ask us to find the atomic number of sodium. What you need to do is just to sum all the index number together, and the summation will give you the atomic number. So now, the index number on 1s is 2, plus the one on 2s is 2, plus the one on 2p is 6, and that of 3s is 1, which is 11. That means the atomic number of sodium is 11. 6. The numeral, or let me say, the index number on the last orbital, or the sum of the index numbers on the last 2 or 3 orbitals of the same energy level represents the group of an element in the periodic table. What do I mean by that? Let's consider sodium, e.g. sodium. You want to detect the group to which sodium belongs. If you go by the first statement, the index number on the last orbital. What is the last orbital here? The last orbital here is 3x. 3s. And what is the index number on that 3x? The index number is 1. Therefore, sodium belongs to group 1. Let's consider this second example so that we can have a better understanding for the second statement written on the board. Let me use fluorine. Fluorine is 9, and that is 1s2, 2s2, 2p5. If you look at this electronic configuration, this is 2s, 2p. So in this case, we cannot talk about the last orbital because we have these two last orbital having the same energy level. So we are going to consider the 2s and 2p. So what we are going to do is to sum the index number on each. That will give us the group. So the index number on 2s is 2. And the index number on 2p is 5, which is 7. Meaning that fluorine belongs to what? Group 7 in the periodic table. I hope you have gained one or two things from the topic explained. And if you have any question as regards this topic, you can drop it in the comment section. And also, if you have any topics of interest that you want me to teach you, please do not hesitate to drop it or to write it down in the comment section. Early Scheme got you covered. Don't forget to share, follow, and like.